Last lesson ended on a shrug. 5 groups, no significant difference, and a warning about testing the extremes you spotted afterwards. That's an uncomfortable place to stop. So this lesson is about the tools you use before you collect anything at all. How much data do you actually need? Can you test 3 changes at once instead of 1 at a time? And what do you use when you have no data whatsoever? Start with the question we left hanging. We could not detect a difference between billing and mobile app. So, how many tickets would we have needed? Measure phase, sample size calculator. And the subtitle tells you where this sits in the wider world: Minitab, stat, power, and sample size. Mode, mean. Significance alpha, 0.05, 95% confidence. Power, 0.8, the Minitab default, which means an 80% chance of finding a real effect if one is there. Standard deviation, 6.81. That isn't a guess. It's the pooled standard deviation straight out of last lesson's ANOVA. Detectable difference, 4.22, the gap we actually observed. Test, 2 sample, n equals 41. 41 per group, 82 in total. We had 46 mobile app tickets, fine, and 33 billing tickets, 8 short. That is the whole reason last lesson couldn't call it, and finding that out took about 15 seconds. Second question. Back in Chapter 9, we had 4 candidate fixes and we picked one of them, because piloting 4 things at once sounds like chaos. Design of experiments is the discipline that says it isn't chaos. If you design it properly. Improve phase, design of experiments. 2 to the k, full and half fraction factorial designs. The default is 3 factors, full factorial, 2 cubed, 8 runs. Let's say those factors are the 3 changes we considered. A. Auto-assign on arrival. B. The midday sweep. C. A severity recheck. And the run sheet is already written for you, in Yates order. Minus means the change is off, plus means it's on, and the 8 rows cover every combination there is. You go and run them and you type in what you measured. Response is in, and the effects come out. B. The midday sweep, minus 2.35. Turning it on takes 2 1/3 hours off first response. A. Auto-assign, minus 0.6. Real, but a quarter of the size. C. The severity recheck, minus 0.3. Then the interactions. AB, 0.25. AC, 0. BC, 0.05. All tiny, which tells you these changes don't fight each other and don't depend on each other. You can simply add them up. The active column flags B and A, and it isn't guessing. Significance here is flagged by length's pseudo-standard error, which estimates the noise from the small effects themselves. The half-normal plot says the same thing visually. Effects sitting on the straight line are noise, and the 2 pulling away to the upper right are real. 8 runs, 3 factors, every interaction between them. That is what 1 at a time testing cannot give you. Third tool, and the simplest in the entire toolkit, the run chart. The same 20 days we plotted in Chapter 10. It gives you the range, 6.1 to 9.8. N, 20, mean 6.68. And it flags 1 Nelson signal at day 12. Now here's something worth noticing, and it's the kind of detail that separates using a tool from understanding it. This chart's 3 sigma limits are 4.33 and 9.03. Chapter 10's control chart, on exactly the same 20 numbers, said 4.62 and 8.74. They differ because they estimate sigma differently. The run chart uses the overall standard deviation, and that outlier at day 12 inflates it. The control chart uses the moving range between consecutive days, which the outlier barely touches. And that is precisely why the control chart is the better instrument for catching special causes. Its limits don't widen to accommodate the very thing you're trying to catch. And the last group, the tools for when you have no data at all. Define phase, 4 of them. CTQ tree. Decompose voice of the customer into measurable CTQs with specs. We built one of those back in Chapter 4. Stakeholder analysis. Map stakeholders by power and interest. RACI matrix. Responsible, accountable, consulted, informed. And the Kano model. Classify needs as must-have, performance, or delighter. Not one of these produces a statistic. They produce agreement, which is usually the thing that's actually missing at the start of a project. So, How much data do I need? Can I test several things at once? Is this thing even moving? And what do we do before any of that? The pattern across all four is the same, and every one of them is cheaper than the mistake it prevents. 41 tickets is cheaper than an inconclusive study. 8 designed runs are cheaper than 4 sequential pilots. Next lesson closes this chapter. The workbench itself, the standalone calculators, and the free public tools you can use without an account at all. See you there.